So, good morning. We are very pleased to see that so many of you made it at that early hour on the first day of TCOM 2023. My name is Jörg Schmidt. I see some familiar faces. Some of you might know me. I'm kind of presenting for 20 years now at the conference. Today I'm here because RWS, or the Tridion Business Unit, did support a master thesis. So, fresh from the press, I'm proud to introduce a new presenter for TCOM, Mette Lilienthal. Hand over to you.
Good morning. I'm here with the Parson AG. They were the people who supervised me. I've also started working for them now. And yes, we're going to present the results of my master's thesis, how to connect a chatbot with your documentation content. We've already introduced ourselves, but we have some other additional partners and aspects we want to introduce briefly before coming to the technical background, the technical setup, the benefits of the chosen approach. We've all been hearing about ChatGPT and others. We'll be providing a different approach to chatbots. And also, because it was a master's thesis, we'll be talking about usability and how well a chatbot for technical documentation content is received. We'll be evaluating all our results and coming to a conclusion, obviously. We've already introduced ourselves. I'm Mette Lilienthal. I'm working for Parson, as I said. We also work together with Bot Friends. They are a chatbot company for this master's thesis, although it's important to say that the results could be achieved with any chatbot framework. We went with Bot Friends because we already knew them from former projects. But yes, that's why we've listed them here too. And like I said, this whole topic was part of my master's thesis.
Yeah, and as mentioned, we as RWS did support Mette by providing an environment. So it is what we call our one demo environment, where we have our full Tridion suite integrated, which is Tridion Docs as the CCMS, the Component Content Management System. It would also have included Tridion Sites as our web content management system, but that was not used. It's not relevant. It would also be including our language solution, so our Trados Enterprise solution to localize the content, which we did not do yet. So maybe next year we might introduce a multilingual chatbot to you. And it would include our headless delivery platform, our Tridion DX suite that could feed the chatbot. So if we have a look at our standard slide, we already have mentioned down there in the lower right corner that chats could be a potential output that we can serve with the suite. And that's what Mette used.
First of all, I'm not sure how familiar everyone is with DITA. I'm assuming most have already heard of it. This is a typical DITA troubleshooting file. We went with troubleshooting because we figured that's what people will use a chatbot for. They'll have a question, they'll have a problem with their device, and they'll ask a chatbot, how can I fix my problem? And this is a typical troubleshooting topic. It's for a pizza oven. We use the fictional pizza oven as demo data. And we said, well, maybe a problem with the pizza oven could be that it's not heating up. And then the user would have a kind of problem. And the troubleshooting steps, the remedies, would then tell the user how to solve that problem, how to get the oven to heat up again. And we wanted the chatbot to be able to access these documentation contents and to actually provide the answer from the documentation. This is the same troubleshooting file. I hope you can read it. You see we have the condition, for example, the pizza oven starts, but it won't heat up. And then a possible cause would be, for example, that the temperature is not set. And to fix the problem, we'd then want to set the temperature control switch. Like I said, this is a problem that we will be looking at when we look at the chatbot itself. Generally speaking, chatbots have been around much longer than I thought. The first chatbot was actually developed in 1966, which is incredibly old, actually. And back then it wasn't called a chatbot, but rather a program which makes natural language conversation with a computer possible, which is basically a chatbot. And also the other things, a virtual agent, an FAQ bot for FAQs, frequently asked questions, or voice bots, that's the aspect of voice control. But the basic underlying function is always you have a bot that you can chat with in natural language. And the thing is, with natural language, that means it's not computer language like Python or JavaScript. It's something that you, as a human, can speak or type into a computer. And this bot then parses the input and translates it into an action, for example, returning an answer. This is very, very basic, but it's enough for how to understand how a chatbot works in general. For this work, we used a semantically enriched rule-based chatbot. What that means we'll be coming to right now. Because for chatbots, there are two general approaches. There's the rule-based approach, which is what we used, where you have a user intention, it's called an intent, and you define these intents with keywords, and you say, for example, for the oven not heating up, then you have the keywords oven and not heating, and then any kind of phrasing, including these keywords, would match the intent that the oven isn't heating. You then have predefined rules, and these rules define how the chatbot is supposed to respond to the detected intent, which makes it a controlled answer. For example, we could say, if you understand that the oven isn't heating up, then tell the user to set the temperature control switch. And because you have to predefine these answers and these rules, and you have to have controlled answers, they work best in small and predictable scenarios. For example, booking processes. If you're offering pizzas, you know which pizzas you have on offer, and you can tell the customers, if you want to offer one of our pizzas, then would you like a drink to go with it? And that makes it fairly easy. On the other hand, which is what we've all been hearing about these last months and years almost, we have the AI-based approach, where the intent is recognized more through natural language understanding or processing. And that means that the chatbot or the program learns a statistically probable answer through, for example, large language models. And again, this is much more technical than what I'm explaining here, but because we didn't choose the AI-based approach and we're having lots and lots of references and topics about ChatGPT and others, I won't be talking about it more. But what we have to know is that they learn statistically probable answers. We can't actually define what they're going to say. And because of that, because they are creative in their responses, one could say, they work perfectly for conversations. We've all heard about ChatGPT writing essays or whatever, and they're brilliant for that because they have a huge set of data and they work well, but you can't actually predict to 100% what they're going to be responding with. And that's why we didn't go with the AI-based approach. We did use a bit of natural language processing to understand the intents. That's why it was a semantically enriched chatbot. But generally speaking, we went with the rule-based approach of actually controlling and defining which answer should be returned by the chatbot. And because this was rather technical, this is an example. This is the chatbot I programmed. And you have an example greeting on the right, hello. And then the chatbot had the predefined answer. If you understand a greeting, then return the greeting. Hi, how can I help you? And then this is the whole magic. You have the problem. For example, my pizza oven smells. And the chatbot then returns the answers, the solutions, the causes, the remedies, typical and the structure for data troubleshooting topics. For example, there's leftover food in the pizza oven, and a possible solution would be to clean the oven so that it doesn't smell anymore. And if we look at this on the left, what the chatbot replied, it's returning exactly the content from this data troubleshooting. So we have, again, the cause, the symptom that the pizza oven smells. We have the possible cause that there's leftover food in the pizza oven. And we have, down at the bottom, we have the step, clean the pizza oven. And that's exactly what we can see here too. And the best thing about this is, not only is it accessing the documentation content, it's doing that basically on its own. Like I said, we went with bot friends to work with it, and right at the bottom, that's the only thing that's important. You can see the responses, and the field is empty. There are no predefined responses. I did not tell the chatbot to say the oven is smelly or please clean the oven, but the only thing that we did was say this could be what the user says, this could be an example utterance, and the response itself comes from the chatbot, from the data documentation. Very briefly, this is the content supply chain we used. We have the chatbot. Like I said, we went with bot friends, but any framework basically would work. I set up a web server to facilitate the communication, and we have the data files hosted and provided by RWS on the right. And very simply put, the chatbot recognizes the intent through natural language processing, sends the detected request to the web server. The web server understands which intent it was because, for example, the intent, the oven smells, matches the troubleshooting file, pizza oven smells, and then accesses that correct data file. and sends the response directly from the web files back to the chatbot, which then provides the output. I did bring some code. I hope you can see it. It's very technical right now, but it's not too important. The most relevant thing is that in the first line, you can see we have the ditta path symptom ditta, and that's how the chatbot knows which ditta file to access. It says it goes to the symptom. For example, oven smells. It accesses the troubleshooting file oven smells. And then it passes through the steps. It looks at the content of the ditta file, and it says it extracts the steps, the causes, the remedies, and gives that as the output. And because a troubleshooting file can have several solutions, for example, we have several remedies. For example, if it's a first remedy, there's a hard-coded part to make it sound more natural, to say maybe, and then the first remedy is provided. And then the chatbot asks for feedback. Does this already solve your problem? And if the user says, no, that's not it, then the next remedy is provided. For example, it could also be that, I don't know, the fuse has switched or something. And the remedies are always sent with the message. It's a possible solution is to make sure that it's not definite, but a suggestion what might help. And then you can see here the send remedy steps. The actual steps are pushed to the chatbot. And like I said, the chatbot always asks for user feedback. Does this solve your question, your problem? And then the user can reply with either yes or no. And depending on whether the user said yes or no, either the next remedy is pushed or the chatbot says, great, thanks for working with me, whatever. This is what we can see here. For the problem that the oven is not heating, maybe the temperature is not set. A possible solution would be to set the temperature control switch. And then the user says, no, this does not solve my problem yet. And then the next remedy is provided. In this case, it could also be that the thermostat is broken. And then the possible solution would be to call the service and replace the thermostat. And in this second case, the user said, yes, this is actually what the problem was. Thanks for helping. And the chatbot ends the conversation with, have a nice day. It could also be, of course, that the user has a problem too specific or too difficult for the chatbot, or that the remedy has not been put into the ditta troubleshooting file yet. And for this case, we also provided back out that then the chatbot says if it passes through the ditta file and it went through all the remedies and the user kept saying, no, this is not it yet, then the chatbot replies, I'm sorry, please ask human maintenance to ensure that we're not stuck in a feedback loop and the user keeps suggesting, keeps asking for solutions and the chatbot only provides the same 3 solutions over and over again. If it went through the file and nothing worked, then it says, I'm sorry, please ask human maintenance. That was the technical background as such. There's more happening in the background a bit, but basically that's it. You have the chatbot, you have the ditta files, and the chatbot accesses the ditta files. And there are 3 main benefits. The first one is that there's very limited training required because we're assuming that if you have this kind of chatbot set up, you already have the ditta files, you already have the troubleshooting, you already have the labeling, the tagging, the everything. So you don't have to set up the troubleshooting anew. And that saves, obviously, time and effort. And because it's not a large language model or some kind of AI, you don't have to train it. You do have a bit of training because you have to train the responses. You have to have the chatbot understand what the user is saying. But the answers don't have to be trained as such because they are accessed by the file. And because they are accessed in the file automatically, it also means that if the file changes in some way, then the chatbot automatically always accesses the newest version. And with an AI model, you'd have to then retrain it or set up a new model with the new answers. And in this case, whenever the original content changes, the chatbot responses go with it. And that's what we can see here. Is it playing? It's probably not playing. It's still not playing, is it?
No, but I see the cursor over here, maybe.
Yeah.
It should be. Maybe next slide. Try the next slide.
Okay.
Now it's running, I think.
Yes, now it's working. Wonderful, thank you. To the left, we have the chatbot, and to the right, we have the data file that's accessing. And we say the pizza oven isn't heating, and it's returning the remedies, the steps. Maybe the temperature is not set. The solution would be to set the temperature control switch. And now we're going to go into the data file, and we're going to change the response. Not much, just to show that it works. And we're saving it. And if we then go back to the chatbot, and we're actually going to go and we're going to copy the same thing twice. So we're going to have this exact same problem, and we're going to paste it and send it. And this time, the chatbot actually replies with the temperature control switch is not set properly. And that's the whole magic. Whenever something in the whenever something changes in the original content, then it automatically, immediately is updated and sent to the chatbot because it always requests the new intent. And to show it more clearly, I took a screenshot. The first time round, it says maybe the temperature is not set, and the second time round, maybe the temperature control switch is not set properly. So yeah, that's the huge benefit I see in it. And also, because we're accessing the files, we have a control data set. We can say exactly what the chatbot is supposed to reply with. And that's the great advantage over ChatGPT and other large language models, because here's the comparison. We're not, I'm going to say it meanly, we're not guessing the answers. We're actually accessing the data file. We're basing it on, for example, XML, and we can ensure that the actual answers we want are provided by our chatbot. Whereas ChatGPT has large language models, and they can be incredibly accurate, and they are great, don't get me wrong, but it's still a statistical probability. And if you have a screw that 50 times it's turned to the left and 50 times it's turned to the right, it's basically a 50-50 chance whether ChatGPT will say it's turn it to the left or turn it to the right, and it might be crucial, and we want to say, no, we actually need this screw to be turned to the right. Having said that, it does mean that there's a larger implementation effort at the beginning for our chatbot, because you have to do the intent matching once, and you have to say which data troubleshooting files you have, and you have to make sure that the intents are recognized, although natural language processing does help there. But once it's implemented, it runs, and it's there. And you can add as many intents as you want, and you can change responses, you can add additional steps, you can add additional remedies within the data file, and it doesn't matter because it's not hard-coded, and the chatbot always accesses the changes automatically. Whereas with ChatGPT or other large language models, you always have the issue of training, and you have to continuously train your chatbot, and whenever you make changes, you have to make additional training possible, and that can be rather tiresome and costs a lot of time. And like I said, we have the controlled environment, we have the predefined solutions, we can actually make sure that the chatbot is responding what we want it to, that it will respond to the exact pizza oven we want and not maybe the competitor's pizza oven, and it's not creative in its responses, we can control exactly what it's going to say. And because it's using our own data, it also has a complete control over our privacy. We can ensure that we are not using the competitor's pizza oven, but our own. And I know that nowadays we have large language models, and that we can buy our own models, and that we can train our own models, but still you have a cloud of data that you're using, and that can lead to a lack of privacy, especially when you're using a general large language model like ChatGPT. But also, even so, you might be muddled up in how, if you have very similar ovens, then the ChatGPT or the models in general, they might get confused which answer to actually access. Whereas with us, we're using our own data, we can ensure exactly what's being used, and that makes it also a privacy concern, and that we don't have. However, there are also some limitations, not quite yet. Or did you want to do it?
No, fine.
Okay. We have 3 components, and the more technical components you have, the more error-prone it is, always. And we have the chatbot, we have the content in code, and we have the data files in the CMS themselves. And I showed you in the code earlier, and we did have some hard-coded phrases. For example, maybe, and then the cause, or a possible solution would be, and then the remedy. And that means that we assume grammatical consistency, and that we assume that the troubleshooting files are always written in the same way and always built up that the troubleshooting language actually matches the hard-coded phrases. Also, I said that it doesn't matter what we do within the file, the chatbot always accesses it automatically and always has the newest version. However, it accesses the file by the named troubleshooting file. Like I said, oven smells, matches the intent, matches the troubleshooting file, oven smells. So if the file name is changed, the intent no longer matches, although that's something that can be fixed with metadata. We'll be coming to that. But right now, this is a limitation we should mention. Also, for this implementation, we're going to be honest, it's not metadata yet. It's only the element tags of the DITA files. We're accessing the remedy, we're accessing the step, and we're not having, for example, this pizza oven instead of that pizza oven. That's limited. That was due to time constraints because it was only a master's thesis. But that's something we're going to be working on and improving, that it actually accesses the right information and content via metadata. With that, over to Jörg.
And that's kind of the point of time where I had to be the devil's advocate in the process of the master thesis, because, of course, we as RWS, we are mainly supporting quite large organizations, so scalability was a big question from our perspective. Would an approach like that scale? And, of course, as Mette already mentioned, there is the problem that all of these topics troubleshooting topics have to be created as troubleshooting topics. I will come to that, back to that later, if that really is a problem in reality, in particular for our customer base. The flexibility is, of course, great, and you can have as many troubleshooting topics as you'd like to have, but the implementation effort, does it really scale if you have millions of topics? We will see. We've seen that the changes to the topic, that's what Mette put in the recording already, in the little demo recording. It's automatically returning the access, but there is a room for improvement from our perspective if it comes to flexibility and scalability, if you're not looking for the file name any longer, if you're looking for metadata. And that's, of course, what we also initially planned to do with the master thesis already. But as Mette said, there is a limited time span for master thesis that you can use. But what, from a Tritium's perspective, we would offer would be metadata management. So this is what we call taxonomy space as part of our Tritium suite. For those of you who know the taxonomy metadata management solutions a little bit, that might look very familiar. Technology-wise, this is Pool Party. That's the Pool Party suite. And the interesting aspect is that, of course, you can build taxonomies in Pool Party. You can, with that, classify your topics so that the search is no longer searching for file names, but for metadata. And as you can see on the right-hand side, not too good, here in this area, one of the big benefits is that with Pool Party, you can have preferred labels for the concept that you're using for tagging and alternative labels. And that, of course, makes the search much more flexible. You don't have to know the exact term that would be part of the file name, most likely. You have to know the concept that you're looking for. And from an usage perspective, so that's our draft space editing tool, where we have the integration with Pool Party available. So on the lower right area, you see some taxonomy values, and these are connected to what we just saw in Pool Party. You could manually select them, but there is also down here, hard to see, the gray button is labeled suggest tags. And if I click on that, it is automatically handing over the content of that topic to Pool Party. Pool Party's extractor component is analyzing, understanding kind of the content, and is suggesting tags. So we, by purpose, do not call it auto-tagging, we call it smart tagging. You do get suggestions, but we keep the human in the loop. And with that, of course, the search would be much more flexible, much more powerful. So that would be a next step. As said, maybe next year, multilingual and concept tagged.
As I said, this was a master's thesis, which means that the university also required some implementation effort. And for that, we decided to go with usability tests for chatbots. And actually, surprisingly enough, there is hardly any official research on chatbot usability. There are some papers and there are some ideas, and I'm sure that every company has their own assessment. But as of 2022, there were no standardized tools available. And there's nothing that says this is the status quo, how to test chatbots. This is what makes a user satisfied with chatbots or not. And there were several maxims for quality assessment that had been developed, but they were based on guesswork, where they put experts in a room and said, well, maybe time saving is important, and probably whatever. They didn't actually test their hypotheses on actual usability tests or users. So for my master's thesis, I developed a usability test and an accompanying questionnaire. And I asked the participants to solve 3 imaginary troubleshooting scenarios. We had the pizza oven, and the 3 scenarios were that the oven won't start at all, then that it would start but wasn't heating, and then finally that the oven smells. We've already seen these topics throughout the presentation. And I also always said, well, the users can't actually know. They don't have the pizza oven, obviously. I'd say, well, that solved your problem. It didn't solve your problem. But I gave the feedback. But otherwise, the users were asked to use the chatbot however they would in real life and just talk. And they were also encouraged to use the loud thinking, to voice their thoughts, to tell me what they were thinking, how they were accessing the chatbot, what they were trying to achieve. And I recorded these tests for text and data analyses. And the results of this I will be showing you now. Just generally to the participants, we had 40 participants in total, 20 female, 20 male. On average, the women were slightly older than the male participants, but generally I tried to get as many people as possible and as a diverse group as possible. So we had people from 16 to 85. We had people from every kind of field. We had social workers, IT people, bank management people, whatever you could think of. I tried to get as many people involved as possible. And of these 40 participants, 2/3 had prior experience with chatbots and 1/3 did not, which is surprising seeing as ChatGPT was all over the news during that time. Several people asked me what a chatbot was. Many people had never used one before knowingly. And so we had 2/3 of participants only who actually had interacted with chatbots before. And for those who had actually gathered previous experience with chatbots, I asked them in which scenarios they had used chatbots. And interestingly enough, the typical use cases, such as bookings, weren't mentioned as often as I had thought. Because like I said, Amazon or whatever, these huge customer support, they all have chatbots nowadays. And you'd assume that that was what people would know. But funnily enough, many people had not known that they were talking to a chatbot or had not used that kind of chatbot before. Also, chatbots in general were mentioned very negatively. Online help was mentioned very negatively throughout the whole test. Everyone had many examples. What went wrong here? What went wrong there? They didn't understand me. They didn't get me. They sent me in a feedback loop. I have many, many companies now from which I know that people are not satisfied with their chatbots or their customer service. They did also sometimes mention something especially positively, to be fair, but mostly the preconceptions of chatbots was a very, very negative one. And not surprisingly, of those who did know chatbots, ChatGPT and Bing also were the best known chatbots, although chatbots people had tested most, used most, interacted with most. But yes, you can see now ChatGPT, major thing, customer service too, but not happily and not willingly. Because of that, when I asked the people, like, are you ready? Do you feel like doing this? Would you be willing to help me? Many were not confident in their abilities of using a chatbot. Oh, I'm not good with technical stuff. Oh, I don't know how to use this. I'm not sure if I can help you. Many, 11 plus 3, that's the 2 columns to the right, many were very, very apprehensive about using a chatbot. And on the other hand, afterwards, many said, well, that actually worked well and that wasn't hard. And we had 33 of the 40 participants saying, well, that wasn't too bad and that was almost fun. And they said, well, all in all, the tests worked well. And I asked the users then to, afterwards, after they had used the chatbot, to assess its usefulness. And I had several questions that were very similar to make sure that the people were actually telling the truth. And for example, the questions, were the responses helpful? And also, did the chatbot help you solve your problem? Which is basically the same thing. 36 participants in both questions answered, yes, the chatbot helped them solve their problems, which, in my opinion, is a brilliant result. Also, in the Outlook, I asked them to evaluate whether they said, in general, could chatbots be useful for technical documentation? And here, again, we can see almost everyone answered in the green area. Many agreed completely, mostly agreed. 2 participants only partly agreed, but there was no one who said, well, no, I can't ever imagine using a chatbot for technical communication. Again, this is something we had hoped for. This is a great result. And I had said that the people were very apprehensive about using chatbots, but when I then asked them to list reasons why they might prefer using a chatbot over human interaction, they found many reasons. And the red column, that was the people, there were 7 answers who said no, they'd always prefer talking to humans and they don't want to have to interact with technical stuff, they don't want to talk to chatbot, they don't have internet access, whatever. But otherwise, there were many, many reasons why people would actually prefer using chatbots. And surprisingly enough, the fact that it was a chatbot and not a human was important to many, because they said they could ask simple questions without feeling like they were annoying someone. They could ask detailed questions without feeling like the customer service would have to search for the results just like they would. They could have the chatbot instantly access the manual. So both simple questions and technical, difficult, detailed questions were both a reason why people would prefer chatbots. And in both cases, the underlying reason was they didn't want to annoy customer service. They didn't want to be embarrassed if they didn't get a troubleshooting issue, if they didn't understand it. They wanted to be able to ask a 3rd time, a 4th time without feeling like they were taking up time and space. Also, the fact that the chatbot has the instant access to the manual, that they wouldn't have to wait for customer service to flip through the pages themselves, but that they could instantly access the right touch point and get the results or the solutions they were looking for, was something that many people mentioned. And going with that, also that the chatbot has all information accessible and is not strewn with that throughout the tech support. And like I said, there were several maxims that some experts had developed, for example, time saving. And yes, that is also something people said in my tests, that the chatbot is always available. You have no queues. You don't have to skip a line or something. That is a major reason why people would prefer chatbots or that kind of technical support over human support. And going with that, also the fast response time. Obviously, we saw it in the video, the chatbot, you text it and it starts replying immediately because it's always online 24/7. That's a general advantage of chatbots. But yeah, all in all, like I said, before they tested the chatbot, people were very apprehensive. They were not happy with it. They were scared almost. And afterwards, they found many reasons why they'd actually prefer chatbots over humans, which I found interesting. And also shows... which leads us to an evaluation, that it shows that the people liked the chatbot, actually. And funnily enough, the participants without prior experience tended to rate the chatbot slightly more positively. 95% of all participants agreed that chatbots can or will be useful for technical documentation content. The chatbot, like I said, was exceedingly well received, despite the previous apprehensions. And the users found many reasons why they'd actually favor chatbots over human support. For example, the availability, the fast response times, the instant access to manuals, and also the fact that they didn't have to talk to humans and could save themselves the embarrassment of not understanding an issue. Also, interestingly enough, a maxim that all the experts had every time mentioned was that natural sounding chatbots would be important and that the people wanted to have the feeling that the chatbot actually understands them, that it answers appropriately. And yes, obviously the users wanted the chatbot to understand them, but the natural sounding aspect, that it sounds like a human, that it has the human language, that it has a natural conversation flow, was not important to many. They said they want their efficient troubleshooting. They know they're talking to a chatbot. It doesn't matter. They just want their responses, they want their answers, and they want it quickly. And the chatbot doesn't have to be polite. It doesn't have to write a friendly essay. It's just supposed to be there as a tool to access the troubleshooting topics, or generally the manuals, and to reply with the responses and the solutions the users are looking for. Which again shows that time saving is more important than the human aspect of a chatbot. Which already leads us to a conclusion. I've shown with the technical information that it is possible to make documentation content directly accessible to chatbots. With natural language processing, we managed to achieve better results in the intent detection with less implementation effort. However, there is more metadata management to be done. Many participants, like I said, were negatively biased beforehand, but afterwards there was an overwhelming majority that rated the chatbot and the user experience very positively. And all in all, this shows that it's not only possible, but also useful to make technical documentation content accessible to users via chatbots. And to show that it's useful, Jörg has brought an enterprise sample as a finishing thought, and then we'll be happy to take questions.
Yeah, as we've seen, that all looks very promising. So I had a look at our customer base and checked what's the status in our customer base. And luckily, I found a customer in the US, Hewlett-Packard, the printer organization, a Tritium customer for a long time. And they use chatbots or have chatbots in place. So if you have an HP printer, you can access support.hp.com and you will be confronted with a chatbot. And you can ask your questions, try to find solutions for your problems. From a scalability perspective, that was a clear check. They are serving millions of customers per month. From an implementation efforts perspective, because that was one of the concerns we had initially, what HP did when they thought about implementing a chatbot 4 or 5 years ago, they did an analysis of the existing chats with the human, how do you call it, support desk, help desks, people. And what they found is that the far majority, I think 90-something%, they didn't share the numbers or didn't allow us to use their numbers. But it was above 90% of the questions that have been raised at the help desk would have been described in the documentation already. It's the old documentation support saying, read the fucking manual first, but nobody does. And so that was from an initial implementations perspective. They didn't have to create new content. They had so much content available already that they could start quite quickly. And also measuring the satisfaction, customer satisfaction. Their results are in perfect accordance with what Mette found with her quite small sample group. Their customers in general are very happy because chatbots are immediately available. They provide solutions in an adequate, quick way. They have a customer satisfaction rate, again, up in the 90% area. And the funny thing is, of course, there is unhappy customers, but they've also digged a little bit deeper and checked why the customers are unhappy. And it's not because they had to talk with a chatbot. It's because the chatbot told them things that they don't like you're out of warranty, your printer is broken, it will require these 25 steps to get it fixed, it will cost you so much money. Yeah, of course, that doesn't make a customer happy, but it's not a fault of the chatbot. The result would have been exactly the same if they would have ended up with a human at the help desk. And so from that perspective, if you have a lot of content in a semantically rich, structured way, like Twitter troubleshooting topics, the time is right. It's quite easy to get it running. If you want to learn more, reach out to Mette or reach out to us. We are happy to help. And with that, we are happy to take your questions.